want to know, if you know the chapter pretty well, teach it to somebody. So if you're going to teach, if you teach this stuff to somebody, you know it pretty well. So I'm going to go ahead and do a quick review, all right? A quick review. That'll be good for Ben because he wasn't here. First of all, early in the year, we had these things called chemical symbols, and we know it's either one capital, one small letter, and they represent elements or atoms, don't they? What about this? We had a whole chapter on this, how to name these things. What do you call these? They're called compounds, but this is called a chemical formula. They represent compounds, don't they? All right. And we had ionic compounds and covalent. And then this thing here, look at this long thing. That's called a chemical, and that's what this chapter is about chemical equations. And on the left-hand side are things that are going to react. They're called reactants. By the way, the next test, first 10 questions are vocabulary words. Okay, so you can already see some vocabulary words right here, can't you? All right, and then what do you have on the right-hand side of the arrow? You have things that are going to be produced. They're called products. Okay, good. You also notice an arrow, and that arrow means makes, forms, produces. It also tells you that on the left side of the arrow, nothing's happened yet. On the right-hand side of the arrow, the reaction's already happened. It's kind of a dividing line between the reaction not happening yet. All right, some additional symbols. S, after the end of it, says it's a solid. L is a liquid. G is for gas. And AQ means I'm dissolved in water. And that means you won't see me. You won't be able to see me. So take a look up here. Solid zinc metal. I guess we can do the first one. Hayden, you want to turn that one switch off? So what we did last week is we said we need to be able to translate this chemistry stuff into English and English into chemistry. And if you take a look at this, it says solid zinc metal is going to react with, and do you remember HCl, what that's called? Starts with an H, so you have to name it like an acid, don't you? So what is this? Hydrochloric acid. And all acids and bases are dissolved in water. That's why I said aqueous. Yields zinc chloride aqueous. What's that going to look like? Water. Because it's dissolved in water, you won't be able to see it. It's in there, you just won't be able to see it. Plus H2G. And what I'll see is little bubbles. Matter of fact, when you do this experiment, not too long from now, you're going to see hundreds of little bubbles take place. And all those bubbles are hydrogen gas. You'll even get to explode that hydrogen gas. Just a little bit of hydrogen gas makes a mini explosion. What you don't want is a lot of hydrogen gas. That makes a big explosion. You know what they use for rocket fuel? Hydrogen gas and oxygen. Hydrogen and oxygen. So we don't want a lot of hydrogen in one place. All right. The other thing, and this is a quick review, okay? So that's why I need your attention. This is probably the most important part of the day is when you're reviewing. And so what we notice is that the way this thing was written, though, it doesn't make sense. Because it says you take one zinc, one hydrogen, and one chlorine, and you can rearrange them and make the things on the right-hand side of the arrow. And that's not true. How did I start with one H and end up with two H's? How did I start with one Cl and end up with two? There's something wrong. And it means it's not what? It's not balanced. We haven't balanced the equation yet. And what we do is, the way we balance the equation, we put these numbers in front of this, which stands for two of these and two of those. And these are called coefficients, aren't they? So we use coefficients to balance equations. All right, is everybody with me so far? All right, the next thing we did is humans love to classify. They love to classify. And you got very, very good at this. What do you call A plus B yields AB? That's a synthesis reaction, okay? It comes together, doesn't it? What about the opposite of that? AB is broken down into A and B. Decomposition. Next, what if you have A plus BC and A kicks out B? See how it got kicked out? And A forms a compound with C. That is a what? Single replacement. And we said in the top one, A is more likely to be a metal because metals are written first in an ionic compound, aren't they? Isn't the positive ion written first? So this metal kicked out this metal. What about down here? D plus BC, whoa. D kicked out C. So what do you think D is? It's written second. Metal or non-metal? Non-metal. So metals tend to kick out metals in a single replacement reaction, and non-metals tend to kick out non-metals. All right. And then the double replacement was kind of fun. AB plus CD, and I'm going to kick you out, and I'm going to kick you out, and I'm going to kick you out. And so two things get kicked out. And so A is going to form a compound with D, and C is going to be a form a compound with B, and that's called double replacement. Okay, so what we did, if you weren't here, is we went through and tried to classify as many of these as we could. Now, we haven't gotten to this one yet. We're going to. We haven't gotten to that one yet. We will in just a minute. We haven't gotten to this, and we will. Okay, let's flip it over. And we did get to these. We classified them. So if you weren't here, take a look and said, does that look like A plus B yields AB? That's synthesis. And this is AB yields A plus B, like that. All right. Now, let's do one just for a quick review then. How about this one right here, number 8? Who can I call it? Luke. Help me out, Luke. Look at this right here. I know it's Monday morning, but what do you think's going on here? It says iron reacts with copper 2 chloride, and so what do you think's happening? How would you classify this one, number 8? What looks like, what's happening there? Do you remember those?
Single reaction.
Yes, single replacement. Single replacement. Okay, now, look what happens then. Iron is going to kick the copper out. Look, it kicked out, didn't it? There he is, right there. And formed a compound with chlorine, like that. Okay, so far? All right. Now, the other thing, and we're going to, let's do one more, and then I'll flip back over. How about J3? Look at this one, number 3. What do you think of this one? And this one, I had a little trick for you before. I said, when you find hydroxide on one side of the arrow, and you find water on the other side of the arrow, right? Water is HOH. Now, can you classify it? What do you think is happening there? Notice that sodium is coming over here and forming a compound with the second part of this, sulfate, and hydrogen is going and forming a compound with OH. Say it again. What do you think? Look at your face is the only way I can tell if you're going on, all right? All right. This one is interesting. It doesn't quite fit the model, but what do you think it is when you only see one reactant and it breaks down? What do you think about this one? It's decomposition. It just breaks down into many things. You get it? So still decomposition. All right, now we've classified all these, and there is one more kind of reaction, which is the hardest one, okay? So far, the first 4, they weren't too hard, were they? Synthesis, decomposition. But take a look at this right here, combustion. All of you like combustion. All of you like to do things like combustion, you know? So here's what we're looking at. Combustion is where you take one of the reactants, has at least carbon and hydrogen in it. It might be carbon, hydrogen, oxygen, but it has at least carbon and hydrogen in it. Are you with me so far? That's rule number 1. One of the reactants has to be carbon, hydrogen. Number 2, you have to burn it. Now, what does burning mean in chemistry? We did this in the candle lab. What does it mean in chemistry if you burn something? React it with oxygen. There it is. So that's why it was being burned. And that's number 2. And number 3 criteria is if it's called complete combustion, you only get 2 products, carbon dioxide and water. So complete combustion, you only get carbon dioxide and water. My furnace at home is a gas furnace, and a lot of you have a gas furnace. The fuel they put in there has only carbon and hydrogen in it, and it getting burned. And that's how it makes the heat to heat my house. Now, the furnaces of today are about 99.9% efficient. The way they adjust it and all that, just the right amount of air, just the right amount of fuel, and it's about almost nearly 100% complete combustion. So what's the only thing that should be produced in your furnace? Besides heat, what are the two products of a combustion reaction? Water in the form of water vapor and carbon dioxide, which you won't see that either. And that goes to that little pipe in the top of your house. It goes up that little pipe, you never see it. Now, if your furnace is messed up, if your furnace, something breaks and something adjustment's not right, the wrong amount of air will be in there, and every once in a while, if you haven't had your furnace checked for a while, it could be out of whack, and it could be incomplete combustion. Now, unfortunately, you'll still get carbon dioxide and water, but what's that other thing that could hurt you that could be produced? Carbon monoxide. And that's why they ask you to have carbon monoxide detectors in your home. Again, if you have your furnace looked at all the time, it shouldn't happen. But you never know. It's a machine, isn't it? Human made the machine, it can break. And that's why carbon monoxide detectors are something you should have, for sure. All right, but anyway, in this chapter, we're only talking about complete combustion there. So let's take a look down here. And do you see this one here, number 7? Criteria number 1, is it carbon hydrogen fuel reactant? Is it being burned? Then what should I put over here? If this is combustion, what should I put over here? Help me out. CO2 plus what? Are you okay? Can you believe that chemistry is actually not that bad? It's pretty easy, a little bit? Okay.
A little bit.
All right. Here's another one. Now this one is instead of just having carbon and hydrogen, it has carbon, hydrogen, oxygen, but it is being burned, and we'll get the same thing here. We will get CO2 and H2O, and it says here this is also combustion. Okay. All right. So now we've actually labeled, we've actually classified. Now this page, unfortunately, did not have any combustion on it. You have to actually go to another page. Let's go to, can you find this page here? All right. Here's what I'm asking you to do, all right? I'm going to ask you to, we're going to do balancing today, and we're also going to, let's go down the road. Hayden, if you'll start out, if you had to classify this one, what would you classify it as? What do you think? There's only 5 types right now. What is it? Yes. I'm going to put that down here. Synthesis. All right, next. Luke. I'll give you a clue. It's only got one reactant. That's usually a clue that it's probably what? Yes. You guys are good. Next. Hayden.
Single replacement.
Everybody look now. Is it metal kicking out metal? Or is it non-metal kicking out non-metal?
Oh.
All right, hang on just a minute.
Good job.
All right, say it again.
It's just non-metal kicking out non-metal.
All right, so fluorine's a non-metal. It kicks out chlorine, doesn't it? Another non-metal?
Yeah.
So it is single replacement, but non-metal kicking out a non-metal. All right, next. All right. A plus B yields AB, synthesis. Next. Gabe.
Double replacement.
Yes, and look at this. Look at this. All right, next. Taylor.
Single replacement?
Which one?
Single replacement?
This one? AB plus CD.
Double replacement?
Yes. Okay. Next one.
Combustion.
Oh, yes, that's a new one. Combustion. Look, criteria number 1, carbon hydrogen reactant. Number 2, burning it. Number 3, did you produce carbon dioxide and water? Yes. All right, next one.
Combustion.
Yeah, 2 in a row.
Oh.
Next.
Combustion.
Yeah, 3 in a row. Next.
Synthesis.
Okay, say it again. I- Okay, hang on. AB plus CD. AB plus CD. That's it. All right, next. Ben, you weren't here.
I got it.
What is it?
Synthesis.
Yep, that's right. All right, next. All right, Matthew. And in this case, watch now. See the OH on one side and water. What if I write the water as HOH? Now, do you see how the sodium kicked out the hydrogen and formed a compound with OH?
Yeah.
What'd you call it again?
Single replacement.
Right. Next.
Number 12.
Uh-huh. Well, number 13 now.
Decomposition.
That's it.
Good job, Sean.
Okay, next. Okay, synthesis. Yes.
Job J3.
Okay. Next. All right, now I'll tell you what. This one doesn't quite fit. It doesn't quite fit. If I had covered this up, what would you have called it? If I'd covered this up, what would you think? A plus B. Right. Now, it is synthesis, but I probably won't ask you like that on the test because it doesn't quite fit the model. All right, next one. Zach. Number 16. A plus BC. It's not the Price is Right. Don't look at the audience. Here.
Oh.
What do you think? Well, you can look at this. A plus BC. See how? What do you think?
Slow.
Okay, everybody quiet. Shh. A plus BC. What do you think? Okay, I'm gonna help you on this one. Okay, watch. This guy here is eventually going to form a compound with the second part of this. So, and who got kicked out? See how this guy got kicked out? So it's either single replacement or double replacement. What do you think? Now, Zach, is it a metal kicking out a metal or a non-metal kicking out a non-metal? And I know that, like I said, I know you missed a lot of stuff the first semester, but wait a minute. Most of the elements on the periodic table are metals, okay? And if you look right through here, anything, not counting hydrogen, but anything below that stair says metal, 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 metal. Okay, see that? Okay, so what do you think? Is it a metal? Do you know where potassium is? So potassium's kicking out who? You know who this guy is? You know what Mg stands for? Yes. So is it a metal kicking out a metal or a non-metal kicking out a non-metal? That's right. Also, on the last one, I probably wouldn't ever ask you this on there because it doesn't quite fit, so I probably won't ask you to classify one like that, okay? Would you say that so far you're pretty good with vocabulary words and classifying?
Yeah.
Okay, now, the next skill that we worked on, and we're going to go back to this again, the next skill we worked on is we have to be able to balance an equation. Balance means that every atom on the left side is accounted for on the right and vice versa. All right, trick number 1. Let's review that, okay? Let's review trick number 1. Trick number 1 is if you see hydroxide on one side of the arrow and water on the other, what should I do to the H2O? How should I write H2O? HOH. If you do that, it's easier to classify and easier to balance. Okay. Also, in this one, there was 1 chlorine on the left side of the arrow, 1 chlorine on the right. 1 sodium on the left side of the arrow, 1 on the right. 1 hydroxide on the left, 1 hydroxide on the right, and 1 hydrogen on the left that was not in hydroxide, and 1 here. And what do I require you to do? If you did not have to add any coefficients, then you have to write the word what? And that means I know that you looked at it and you saw it was already balanced, okay? All right. Trick number 2. Look at question number 3. As I scan through here, do you see where that says O2? And see this where it says O3? How can they ever balance? How can an even number ever balance an odd number? They can't. So what's the trick? What's the smallest number that 3 and 2 both go into evenly?
6.
Okay, what times 2 is 6? And what times 2 is 6? Or 3 is 6 again? So what I did is I put a 3 here and a 2 here. Now, watch now. How many oxygens on the right? 2 times 3. That's 6 oxygens on the right-hand side. How many on the left? 6. That's balanced, isn't it? Oxygen is balanced. But look at iron. How many irons on the right-hand side?
4.
So I had to put a 4 here. And because it's trial and error, you have to ask yourself, can I reduce it? Can I divide all of these by some number to reduce every number? Or am I done? Can I reduce this? 4, 3, 2? No, I'm done, right? Now don't write the word balance. I know it's balanced. But balance means if it's already balanced, you didn't have to do anything to it. All right, let's go down to another one. Here's another odd even mismatch. Take a look. I had O2 here and O5 here. What's the smallest number that 2 and 5 go into? 10. 2 times 5 is 10. 5 times 2 is 10. Now the oxygens are balanced. But how many how many phosphorus does that give me? 2 times what?
2.
That's 4, so I have to put a 4 here. Can it be reduced? Okay, you ready? So that's trick number 2. Trick number 3. As you look through here, do you see this thing called sulfate? You have to learn your polyatomic ions. Did everybody get that? I let you get by on exam. But SO4 I use all the time. What's it called? Sulfate. All right.
Sulfate.
How many sulfates are on the left side of the arrow? Don't say 4. How many sulfates are there? 1. SO4. Sulfate, right? How many sulfates are on the other side?
9.
How many? 3. So that's why I had to put a 3 here. If I put a 3 here, it gives me 3 sulfates, but it also gives me how many coppers? 3 coppers, 3 coppers. But wait a minute. I had 1 aluminum here and 2 here, so I had to put a 2 here. Can I reduce this? Okay, what do you think? Okay, so far, there's your tricks. Now, I want to show you something on number, let's try another one. Look at number 7, okay? Now, a lot of you, I was your age at one time. A lot of you think you're pretty smart. That's okay. It's okay to think that. Some of you think you're the best basketball player in the school. That's okay. You can think that. You got that? But let me ask you this question. On number 7, I'm going to give you a minute. I'll give you a whole minute to balance it. And let's see how smart you are. Ready? Number 7. Go ahead. Balance number 7. Now try your best. Tell me you're going to try your best for 1 minute to balance number 7. See if you can balance number 7. I'm sure there are some of you who thought, wow, this is so easy. And then now, how about this one? What do you think about number 7? Now, if you're talking to somebody else, that means you're done. Are you done? Sean, you got the numbers for me? All right, what do you got? What are you going to put here?
Put 4 there.
A 4? Okay. What are you going to put here?
I put a 2.
2?
Yeah.
What are you going to put here?
2.
2? What are you going to put here?
About
4?
4.
Okay, let's take a look. Well, first of all, I know you could have reduced that because 2 and 4, you could have divided it by 2, couldn't you? That's okay. We'll fix that. Let's take a look. If you put a 4 here, 4 times 8 carbons. 4 times 8 carbons is what? Oh, I'm not sorry. Wait, how many carbons is that? 8? Yeah. 4 times 8 is 32, Sean. That's 32 carbons. How many carbons do you have here? 2 times 1. That's C1O2. 32 balances with 2?
Wow. I thought it was 2 times.
Huh?
I thought it was 2 times 2.
Okay, so anyway, all right, somebody else who thinks they have it. And I can tell you right now that when I was your age and I was trying to balance one of these, no one ever told me there was a trick to it, and it was very frustrating. I tried it. I tried something else. And it was very frustrating. So I'm going to tell you why you're having trouble balancing number 7. I'll tell you how to fix it, okay? For a combustion reaction, I want you to take a look. Is that an 8? Yeah. Okay. At first, you might say there are 8 carbons, so I think I'll put an A here because 8 times 1 carbon is 8 carbons. And I understand that. Notice I wrote it really lightly because I know I'm going to change it. But take a look at hydrogens. How many hydrogens do you have here? Everybody look at me, okay? 18 hydrogens, right? Now, you're going to put a 9 here, aren't you? What's 9 times 2? That's 18 hydrogens, right? It will never balance. If I do that right there, it will never balance. And let me see if you're... Can I go a little bit higher level with you guys today? Just a little bit? A little bit? Do you know that no matter what you put, what's any whole number times 2? Is it even or odd? Any whole number times 2. 7 times 2, 3 times 2, 5 times 2 is even, right? I have to have an even number of oxygens, don't I? Now look on the right side. What if I put an even number here? What's even times 2? That's even. What about an odd number? What if I put a 3 here? What's 3 times 2? Even. That's okay. Look over here now. What if I put an even number here? What's 2 times 1? Even. What's 4 times 1? Even. If I put an even number here, what's even plus even? What's 6 plus 4?
10.
That's even. Even plus even works. But what if you put an odd number here? What's an odd number of oxygens plus an even? Odd. Take any odd number and add it to an even number. 3 plus 6. Odd, isn't it? If you put an odd number in front of that water on a combustion reaction, it will never balance. So what's the trick? See that 9? Make it double it. Now try it. Ready? Everybody put an 18 in front of that water. Now try it. So trick number 4. In a combustion reaction, if it looks like they're trying to force you to put an odd number in front of the water, don't do it. Double it. If everybody put an 18 here, what's 18 times 2? 36 hydrogens. How do I get 36 hydrogens on the left side? 2 times 18, right? Now the hydrogens are balanced. How many carbons do you have now? What's 2 times 8? So what do we have to do over here? Remember the CO2 is how many C's are there and how many O's are there? 1 C and 2 O's. Ready? So what's 16 times 1 carbon? Isn't that 16 carbons? 16 carbons on the right, 16 carbons on the left. Now, watch for oxygen now. Watch here. It's kind of fun. What's 16 times 2? 32. And what is 18 times 1? And what's 32 plus 18? I'm going to try it again. 16 times 2 is what? 32 oxygens. And what's 18 times 1? 18. How many is that? I need to have 50 oxygens on the left. What am I going to put here to get 50 oxygens?
10.
Ooh. You're disappointing me. 2 times something equals 50. There we go. Now, can we reduce it? Can we reduce it? Nope. All right. On a combustion reaction, some of them are easy because they'll let you put an even number here. But if it looks like they're trying to make you put an odd number here, you double it and you'll be okay. Now, when I grade your homework, everything on here should be done. You got that? It's your responsibility to make sure everything on here is finished. Is there anything on here we haven't finished? All right, go ahead and do that one. Try that one. Try number 4. You're gonna it's kind of neat. Some of you are gonna be really good at balancing equations because you like the numbers thing. By the way, number 4 is something that you had in 9th grade. All right, raise your hand as soon as you think you figured it out. Are we still getting used to this a little bit? Oh, trick number 4, I'm sorry. Can I show you another trick? Notice there's oxygen here and oxygen here and oxygen here and oxygen here. Do not balance oxygens first. Save them to the end. Do you get that? Don't try to balance oxygens first. So what do you have here? How many carbons do you have here? 6. So how do we get 6 carbons over here? 6 times 1, did that do it? Okay, don't do oxygen now. How many hydrogens over here? 12. What's 6 times 2? Okay. Now let's do oxygens. 6 times 1 is what? 6 times 2 oxygens is what? What's the total? I need 18 oxygens over here. But be careful, I already have 6 of them here. So how many are left? I need 18 oxygens, but there's 6 of them, so I need what? 12 left? Woohoo! Does that do it? Does anybody happen to know what this was from 9th grade biology class? You do it all the time. You do it millions of times a second. Every one of you. What?
Breathing.
Cellular respiration. Wow. That's amazing. Look, glucose. You take in the mitochondria, glucose combines with oxygen. It's called, all right. And what are you giving off right now? You're giving off CO2 and water. All right. The bottom one. Ready? It almost got cut off here. Let's see how smart you are, okay? Hydrogen reacts with oxygen to produce water. Let's see if you can write it all out and balance it. And by the way, if you weren't here the other day, you probably don't know why we wrote all these down here. But everybody else, somebody got $1. Did I run out of dollars?
Yeah, I got $1.
Okay. No, that was $1 for something else. Did I run out of dollars for this one?
Hey.
Did you get that one? I thought you got it. I'm gonna give you $1 here. Because I ran out of dollars, but when I got my hair cut, I got some change. So
Bart Simpson.
here, give that to her. All right. Anyway, so when some elements are by themselves, not in a compound, but in themselves, they're called diatomic elements. Everybody got that? Okay, so now when you go over here and you're getting ready to do this one, and we're almost done. Everybody pay attention. We're almost done. It says hydrogen reacts with oxygen. Now, if you did this, then everybody could be a chemist, and you would fail. So what am I going to write for hydrogen? When hydrogen's by itself, what am I going to write?
H2.
H2. reacts with oxygen. Oxygen by itself. What am I going to write?
Uh,
Isn't it a diatomic element? And how do I write water? Now, I don't need to write HOH because I didn't find hydroxide. See that? Now, how do I balance this?
You gotta put 2 nitrogen
To where?
in front of the H.
Here? How do you know that? There's only 2 here and 2 here.
I'm talking about you gotta do 4.
Why? Because I see 2 here and 2 here.
Nah, because there's for the oxygen.
Oh, so 2 oxygens, 1 oxygen. Now how many oxygens?
2.
2, but how many hydrogens?
4, so you put 2 in front
That's
of the
what I
H.
said to do.
I know, but I asked you why. Why did you put it there?
Because I was just like,
All right, hey, you did a great job. You did a great job today. Great job. Zach, you need to learn the first 20 elements. All right, every time you look at a periodic table, you should be able to say hydrogen, helium, lithium, beryllium. Okay? Do you have a periodic table? It's in your book. I want you to be able to know the names of the first 20, then we'll do the next 20, all right? All right, Gabe, quick. Real quick, I want to talk. Last week we were talking about how we wanted to look at your exam and maybe I could adjust the grade, but see, we only met once and we didn't even go over a lot of questions, and you didn't show up on Friday. I thought you were going to show up on Friday. So here's where my point is. I don't want to adjust your exam grade because you came in one day and ate lunch with me. We talked about it, but when are you going to show me that some of the ones you missed, you actually do know them, or how do I know that you didn't really deserve the 38 on that exam? How do I know that? Because I thought you were going to come in on Friday because we only got to a certain point. Remember that?
Yeah.
So it's not like all of a sudden I changed Dave's exam grade to another grade because he showed up one day. What I'm looking for is that you showed me that, we went over either a lot of the questions or you showed me where you made your mistakes. And I'm not sure that happened. So anyway, I wish you would have shown up on Friday because that makes it a situation where either you show up today or, I don't know, after school I have a meeting. I don't know what to tell you. Yeah, I'll have to think about. What do you think about that? Because I don't think we went over enough questions at all. So I was trying to get you to the point where you thought, oh, I knew that, or oh, why is that answer B? And then you were going to ask me questions and things like that. But it seemed like the only thing I got done was I was trying to explain to you how to get the answer. But anyway, I don't know if you have time today. If you don't, that's okay. But all right.
Of course.
Thank you, Mr. Feeney.
Welcome.